restructured video. I'm discussing integers under subtraction. And the problem that we're working with today is negative 15 minus negative 27. So one trick that doesn't necessarily use the conceptual understanding, but is an easy way to remember, is to turn a minus a negative into a plus. It's adding a positive. Since it's two negatives, they would cancel out and just make a positive. Yes, that's one way to look at it, but to really conceptualize it, it's important to understand zero pairs and why this really does turn into adding. Why does that happen? So I'm starting with a negative 15. And I drew out the little counters. I'm trying to not use manipulatives here, but I just wanted to put the little dots to represent the different numbers here. So I have negative 15 is what I'm starting with, right? So I made the red dots negatives. So they're negative 1 for each of them. There's negative 15. Now these two parts together equals 0. A negative 27 and a positive 27, because each of these basically is the inverse. The red is the inverse of the yellow. So basically they make 0 or cancel out. So essentially we could say this whole big area here is 0. So I have my negative 15. Now I want to subtract negative 27. So I'm actually going to go in here, take this negative 27, and get rid of it. Nope, no more negative 27. Now we notice we have the positive 27 and the negative 15. Now all of a sudden we have our negative 15 plus that positive 27. To make this easier to add, we can use our commutative property. So by commutative property, if you're adding two different numbers, integers in this case, we can reverse the order or change the order of them. So it'll be 27 plus negative 15. Either way here, we know that we have 27 and negative 15. That's going to come out to 27, 15, going to come out to 12. So that is going to be our end here. So we can notice up here, how does this happen here? So we have our 0 pairs here. Now that we have the negative 15 and the 27, we can actually take 15 of these out. So one might say this could be 27 minus 15, but why is that? Because I'm going to get rid of this negative 15 here and find it 0 by finding its 0 pairs in here. So I have 15 here. 1, 2, 3, 4, 5, 6, 11, 12, 13, 14, 15. 15 here. Get rid of those. We're going to have 12 remaining as we get rid of these. So we're basically finding inverses to create 0 pairs. So we're able to make this problem a little simpler. So personally, I find that the shortcuts are easier for students to remember, but they're not necessarily going to know what they're actually doing. And I think in really studying this material in this module, it's really helping me to understand, even for myself, what exactly is going on here. And in that way, find ways to instruct my students in how they can understand these topics and therefore apply it to more advanced algebra skills.